Good evening, everyone. Welcome to our August Core Advocate webinar, Don't Make Every Math Strategy a Separate Lesson, Developing Understanding and Skill with K-4 Operations. We're excited to have all of you join us this evening. We're just going to take another minute for everybody to join and just to see if we get any more Core Advocates on the webinar this evening. So while we're waiting just for another minute to begin our webinar, we would encourage you to use the handout tab that's on your control panel and download the handout that's for tonight's webinar. It's a PDF, and we actually will be referring to the handouts and asking you to look at it during the webinar this evening. So everybody's going to want to make sure they have the handout downloaded. And we'll begin our webinar in just another minute. Great, thank you. Hopefully everybody is able to download the handout, and we're going to actually start our webinar off this evening with a poll to find out a little bit about who we have on the webinar tonight and how many webinars each of you have attended in the past. So you're going to use the poll tab and go ahead and just take the poll that we have here and let us know, is this your first Core Advocate webinar, or how many webinars have you joined in the past? Great, so it looks like we have most of you tonight joining us. This is your first Core Advocate webinar, so welcome, and we're glad that you're here, and we hope that you will find this valuable use of your time this evening. And it looks like the next group has attended between 1 and 8 webinars, and we have a few people who are seasoned Core Advocate webinar attendees who have attended 9 to 14, and even maybe somebody who's attended as many as 15 webinars. So welcome, everybody. Thank you for joining us. We're going to go ahead and get started. So again, this is Don't Make Every Math lesson, every strategy a separate lesson. And joining you this evening from the Student Achievement Partners Professional Learning Team are myself, Jenny Beltramini, my colleagues Tori Filler and Nicole Bravo. And this month's presenters also from the Professional Learning Team are Marnie Greenstein, who's a senior math specialist, and we have a special Core Advocate guest joining us this evening as well, Muriel von Aspen. So we want to tell you a little bit about the Core Advocate Network, especially since so many of you are joining us for the first time this evening. Core Advocates are educators from all over the country who believe in the potential of high quality standards and the importance of all students being prepared for college and careers. And they support their colleagues in understanding and advocating for the standards and embrace the shifts in instruction required by the standards. The Core Advocate Network is over 10,000 educators strong, and we'd love for you to join us if you have not already. If you want to learn more about the Core Advocate Network, you can certainly email me. My email is on the slide. You can also complete our survey, take a short survey to join our Core Advocate database, and you'll receive our monthly Core Advocate newsletter, which will tell you about our upcoming webinars and virtual learning opportunities. And the link is there on the slide, or you can also visit our website at achievethecore.org. And we want to let you know that we are active tweeters, and so we hope you'll engage with us in this way during and after the webinar as well. You can use the hashtag #CoreAdvocates, and you can follow us on Achieve the Core on Twitter, and also myself at Jenny Beltro, my colleague at Marnie Math, and our Core Advocate guest is also on Twitter at Muriel Von Aspen. So we hope that you'll engage with us, like I said, during the webinar and even afterwards. So we're going to have lots of ways for you to engage with us tonight during the webinar. One is accessing the document that's available. So we hope you've all found that on the Handouts tab and been able to download the PDF in the Handouts tab tonight. We actually will be referring to the handout during the webinar tonight and asking you to look at it. Also, we're going to ask some questions during the webinar, and so you'll be using the question tab on your control panel in order to answer the questions. And you won't be able to see what everybody else answers, but my colleague Tori and I will be replying all to some of them so that we can share them out with you. And like the poll that you just took, we'll be using that as well. After the webinar, we'll send you a survey, and we ask you to please take a few minutes to fill it out to give us feedback. We always look at the survey results and learn from your experiences to figure out how we can make our webinars more valuable for you. And in that email that you get, you'll also get access to the recorded webinar as well as the original PowerPoint and all of the handouts so that you can look at it again and share it with your colleagues and even maybe use the materials yourselves. So we're going to go ahead and dive right in now and get started. The goals of the webinar this evening are going to be to understand the relationship between conceptual understanding, procedural skill fluency, and know from memory in the standards. Analyze the grades K through 2 progression that ends with fluently adding and subtracting within 20, and also analyze the grades 1 through 4 progression that ends with fluently adding and subtracting multi-digit whole numbers using the standard algorithm. So we're going to start with section 1, thinking about what is the relationship between conceptual understanding, procedural skill and fluency, and know from memory in the standards. So I'm going to go ahead and pass it off to my colleague Marnie and let her introduce herself, and we can get started.
Hi, everybody. My name is Marnie Greenstein. I'm the Senior Mathematics Specialist at Student Achievement Partners, where my work is really about supporting educators with aligned instructional materials and instructional practice. I'm really excited to be here tonight to talk about the progressions in K-2. We get a lot of questions from school leaders and district leaders about how to boost student achievement in 3rd grade and up in the testing grades, and I think the answer really lies in doing K-2 right, and there's so much to get right. So 2 caveats before we start the webinar. The first one is that, unfortunately, we're not going to be able to get into everything about addition and subtraction within these 45 or so minutes, but we're hoping to provide some ideas and some activities that you can bring back to your classrooms and your schools. And the second is this is going to be a bit of an interactive webinar, so there's going to be things to read and watch and chat about, so please participate as much as you can and make sure you have those handouts ready. So we're going to start, usually I like to start sessions by having people do math together, but since we can't do that, we're going to start by watching a student doing some math. So this is a 1st grade student working on the set of related addition problems that you see at the top of the screen. And as you watch, just think about what concepts and skills does she know? And then we're going to ask you to type that into the question box at the end of the video.
Because 5 plus 5 plus 3 is 13. That's 5 and 6. 22. There's 22 here.
Can you show what you did?
And then I did 5. And then I did 5.
And how did that get 22?
Wait, oh, 2, 6, 2.
How did you get that?
5, 10.
So hopefully you could catch some ideas that the student's working on. And if you can go ahead in the questions box and type in things that she knows or is able to do.
Great. So many of you are noticing that she knows how to make a 10, and many of you noticed also that she can count by 5, and even some doubling or skip counting by 5. So lots of things that many of you have noticed. So thank you for sharing.
Yeah, and I think noticing the make a 10 and the fact that she's got an understanding that finding sums that make 10 make these problems easier is super fundamental to the work that kids are doing in K2. So that's a little clip from the middle of the progression, and we're going to take a look at this learning that really spans the K4 years to get students to have a deep understanding and fluency with addition and subtraction. So the next part of this webinar is a pop quiz. I'm sure that's what you signed up for on an August night. In the handout, the very first page in there has a table of standards. These standards are pulled from kindergarten to 4th grade. They don't have the grade level listed, but they do have the domain. And go ahead and spend a few minutes trying to figure out which of those standards belong in each of the grades from K to 4. So I know that wasn't nearly enough time to be able to go through all of the standards and sort them, but hopefully you got a chance to get in there a little bit and think about what language in the standards show you the progression. So I'm not going to show you an answer key for this, but you can go to corestandards.org/math and look at the whole standards as they're written and match them. But what we're going to talk about through the rest of the webinar also will be sort of an answer key for figuring out the answers on that one. So what's really evident when you read the standards carefully is that there's a very clear multi-year progression to help students develop addition fluency. And so the standards recognize that this takes time. It's not the work of a single grade level, and that there's conceptual understanding, procedural skill, and fluency involved in that trajectory. The other thing that you'll notice is a lot of the work within the OA domain, the operations and algebraic thinking, is setting kids up for the algebraic work that they'll do in middle school. So the idea here is to go slow, to build that progression so that students can really focus on deeply understanding addition, subtraction, and place value, which is the big idea of K2. One thing that's important to think about with this progression is it really allows teachers to collaborate, to know exactly what their responsibility is at their grade level, know what students are coming from and what they're going to, so that the work of developing students' addition fluency becomes the work of K4 teachers together. One of the things that you'll notice in the standards is that the language of the standards differs between procedural skill and fluency. When we talk about this aspect of rigor, we talk about them together, but there's actually a hierarchy of how these things work. So there are a bunch of standards throughout the K-12 that are procedural skill and fluency standards. Within that, there is a small set of standards that use the word fluently. In fact, there are 10 standards, and they're all before 8th grade, that name fluently. And it was a really purposeful choice to limit that. And then within those fluency standards, there are only 2 standards that are know from memory standards. So you'll see that in 2nd grade with addition facts, and you'll see that in 3rd grade with multiplication facts. And again, this was a decision to really narrow in on what's most important for students to be successful. If students are not able to quickly add their single-digit facts, then doing multi-digit addition and subtraction is going to be a real challenge. So thinking about those systems and what we know about conceptual understanding to procedural skill, which of these diagrams resonates with you as you think about helping students develop conceptual and understanding and procedural skill? So go ahead and use the questions tab on your control panel and tell us which diagram resonates and why.
Great, thank you for your answers. My colleague, Tori, and I will continue to share out some of what you were saying. Most people, I think actually almost everyone that I've seen, has selected diagram number 2 that resonates with them mostly. And the idea is that it's not a linear process. It's a cycle, it's cyclical. As students get fluent with certain numbers, they can go back, think more about conceptual understanding and build more understanding and more procedures based on that. So we've got lots of really great answers about which one resonates and why. So Tori and I will continue to share those out.
Great, thanks. And I think that this is a bit of a shift from thinking about it just as a trajectory to the idea that these things keep building on each other and keep helping students develop more and more mathematical knowledge as they get older. So we're going to start the next section by really zooming in on kindergarten through grade 2 and thinking about how that progression help students to have fluency within 20 by the end of second grade. So I forgot to explain this the first time that we showed this slide, so I'm glad it's in here again. So this progression and the circles show where conceptual understanding is required in the standards versus where fluency. So where you see the full light blue circles, those are saying that in that grade level, there's an expectation for fluency with that range of numbers. And the half-filled circles show us where students are working within that magnitude, but not required to have fluency. So when we look at the OA progression, we see that fluency has a really clear path. K is within 5, 1 is within 10, and second is within 20. So one of the interesting things, if you look at the cluster headings in first and second grade, we're on the next slide. The two cluster headings are exactly the same. So the work of first grade and the work of second grade is about adding and subtracting within 20. When we look at the language of the standards, we can see the difference in terms of the expectations. While they're working within 20 in first grade, we're really thinking about strategies that are going to be helpful for students to get to the fluency that's required in grade 2. So this kind of helps us see how kids move along a trajectory as they are getting older. The next slide has a quote from the Counting and Cardinality and Operations and Algebraic Thinking progression, which I think is really powerful when we think about the role of a teacher. So fluency in each grade involves a mixture of just knowing some answers from patterns. For example, adding 0 yields the same number, and knowing some answers from the use of strategies. It is important to push sensitively and encouragingly toward fluency of the designated numbers at each grade level, recognizing that fluency will be a mixture of these kinds of thinking, which may differ across students. And I think this quote is so important and highlights what makes teaching K2 so challenging is thinking about the range of students that you have, where they are, and how to help push them sensitively and encouragingly towards fluency with the grade level expectations. So there's a really great resource to help think about where your students are on the progression. This table is on the second page of your handout, and it is an excerpt from the Counting, Cardinality, and Operations and Algebraic Thinking progression document. This is from the appendix. And so what I'd like everyone to do is just to take a few minutes and read that page and think about how this information can help teachers move students along towards fluency. So hopefully you had a chance to skim over the levels, or maybe you're already familiar with it. So we're really thinking about level 1 is counting all, level 2 is counting on, and level 3 is recomposing or using related facts. So what we're going to do now is get a chance to watch another kid who's sharing their thinking around addition and subtraction. You'll find on the next page of your packet there's a table, and it is going to show you the problems we're going to see the student solve. You're going to decide if it's something students know from memory, and then if they don't, you're going to try to identify which level of strategy he uses to figure out the fact. So let's go ahead.
How did you figure that out? Because I was using my phone. 5 plus 2. 7. How did you know that one? 10. 8. 7. So you go 6. 7. Plus 5. 3 plus 5 equals 8. How did you know that one? Because 5 plus 3. 4 plus 10. 4 plus 10 equals 14. How did you know that one? I learned it in school.
I'm guessing most of us have had a student in our classroom that answers the question of why with, I learned it from school or my mom told me. So hopefully this clip is helpful for thinking about analyzing specific student responses. We have our answer key on the next slide, which points out when it seems like the student knows the fact from memory versus when he seems to be using a strategy. And so it seems like for both of the facts he didn't know from memory, he used some kind of counting on. The 3 plus 5 one is a little harder to see whether 5 plus 3 was a fact he knew or whether he counted on from there. We're going to watch one more quick video with 2 new facts on them so that now we're at the bottom of the recording sheet. We're going to look at the facts with missing add-ins. And again, think about whether he knows it from memory or which strategy he's using.
Four plus something equals 8. 4. How did you know that one? And 4 plus 4. Something plus 5 equals 9. 4. How did you know that? Because of the other math problem. Which other math problem? The one that we just did.
So with those 2 facts, we can actually see how a student being fluent and knowing from memory their addition facts can help with missing add-in, which relates to subtraction, which is really starting to bring in that operations and algebraic thinking in the K2 band. So we have a little answer key for you on the next slide. And as the note says, you know, it's not always so clear how the student is coming up with the strategy, so the opportunity to ask them what they were thinking about is super important. And with that student, I would want to probe a little bit more about how he came up with the 4. So the title for this webinar is inspired by the fact that although we know that there's this progression that's needed and the progression documents tell us that students are moving along at a different pace, that's not how most instructional materials are set up to deal with developing students' fluency. So on the next slide, you'll see a non-example that we find all too often in textbooks. So this is the first grade. This is the chapter 3 where students are working on adding within 20, and you'll see that each day there's basically a new strategy for students to work on. And so this gets really challenging if on the 3rd day of the unit, all students haven't mastered doubles, then to give them doubles plus 1 on the next day isn't necessarily going to be a strategy that makes sense or works for them. So this sequential nature as unconnected strategies isn't helpful for students and sometimes can hold them back. So on the next page, we have an example that it shows kind of how instructional materials can get in the way of students developing fluency. If you look at this problem, you can see at the very top that the student wrote the answer. We don't know if the student just knows it. We don't know if they use a strategy, but it seems like they just had the answer without having to do the work that's required of them in the box. And then they're trying to figure out what they're supposed to do. And maybe it's make 10, and maybe it's write some facts that go to doubles or near doubles. But we just took this student back a step where he's already thinking about them fluently. It's not a necessary step to ask him to use a specific strategy or to choose one of the strategies that are there. So this, I think, is where teacher discretion comes in a lot. And if we're thinking about really helping push students encouragingly and sensitively, it has to be thinking about where specific kids are at and helping them move and build on what they know. One last thought to leave you with the OA domain is the next slide that we have shows a very tiny addition table, and this was made by Jason Zimba to think about how students can master facts. And if you look at the color coding, you'll notice there aren't any doubles or doubles plus one facts, because when you look as students are moving past addition within 10, pretty much all of the facts that we think of as harder facts can be used through making a 10. And so thinking about really prioritizing that as a strategy that's going to last students beyond just these facts and really help them as they get into larger number computations. And there is a tiny URL if you want a bigger version of that table. So I'm going to pass it over to Muriel, who's going to talk about how that work with OA and fluency within 20 gets extended into the number and base 10 domain in 1st through 4th grade.
Hello, everyone. I'm Muriel Bonaspen, and I'm an instructional coach with Saddleback Valley Unified in Orange County. I work at a dual immersion Title I school, and I am a core advocate. Next slide. Next slide. So once again, as Marnie was saying earlier, let's go back one, please. We can see on this chart how the conceptual understanding of adding and subtracting numbers in one grade becomes a fluency in the following grade. And the fluency with smaller numbers supports conceptual understanding with bigger numbers, as Marnie was saying earlier. So as you can see, if we look at 3rd grade, the conceptual understanding that they acquired in 2nd grade for adding and subtracting within 1,000 will support their work in becoming fluent in 3rd grade. And then they reach 4th grade, where the standard for MBT 4 calls for adding and subtracting multi-digit whole numbers using the standard algorithm. So by this point, students should have a solid conceptual understanding of adding and subtracting based on place value, and they should also be competent with various strategies so that they can make the connection to using the standard algorithm for adding and subtracting bigger numbers. And the standard algorithm at this point is an efficient representation of everything they have learned in the previous years. So in the next slide, you are going to see a lesson that I did with my 4th graders. And this was the very first lesson I'm adding multi-digit whole numbers using the standard algorithm. So I posed this problem to my students. Last month, Tula Market sold 3,452 tacos and 670 tortas. How many tacos and tortas did they sell in total last month? And I asked them to use a model to show their reasoning. So in the next slide, before I even post the problem, I asked students to name the representations they used to show their thinking when adding and subtracting in 3rd grade. And this is what they told me. They said they had used a number line, they used expanded form, they used based on blocks, they used a place value chart, and they use equations. And the reason why I did that is because I wanted to activate their prior knowledge, and I wanted also to connect their previous learning to the new learning of this lesson, which was going towards the standard algorithm. So in the next 3 slides, we have samples of the student work, which you will also find in your handout. And what I like to ask you to do is to take some time to look at this student work and select some that you would use to add to the chart, to a chart like the one that I had, in order to facilitate the learning of this standard. So which student work would you select to share, and how would you sequence them? And in your handout, you will see that there are student names associated with each sample, so you can include those as you use the question tab to give some of your ideas.
Great, we see a lot of great answers coming into the question box. We're going to start sharing out a few trends that we saw. I think the majority of folks talked about how they would start with Jake's student work. And that being because it's the most pictorial of all of the student responses. Many folks thought that moving from Jake to something like Bernard, Jacob, Lillian, and ending with Ashley would be a good way to go. Ashley showing the most conceptual understanding and using the bridge from place value to algorithm, thinking forward. Jenny, did you see anything else?
No, I think we saw a lot of, and I've just been trying to share some of them out so you can see what other people are writing. But most people have said, starting with the pictorial, going more to abstract or less concrete, or building toward the standard algorithm. Some people have even mentioned the ones that connect, using the ones that connect with place value to sort of bridge to the standard algorithm would be a good way to think about sequencing the student work. So we can go back to Muriel now, and she can share with us what she chose to do.
So obviously there's not one right answer, and I'm sure that we all have different reasons of the work that we would select to show this progression. But in the next slide, I'd like to show you what I chose and show the reasoning behind. So I started with Jake's representation, as many of you said, which shows baseline blocks, because she shows a very concrete model that the students have been working on since the early grades. And it's also very clear to see the strategies that the student is using. He's adding thousands to thousands, hundreds to hundreds. He's also making 100 with the tens, and he's making 1,000 with the hundreds, and then regrouping. So that was a very clear way for all students to understand how that student is adding those bigger numbers. And then I continued with Jacob's work, which uses this expanded form, because it also is a clear connection between the baseline blocks and their value to this form. And again, through the expanded form, you can see that the student's understanding of place value is there, and that he's using regrouping as a strategy. Then I follow with Morgan's place value chart, just because this is more abstract, but it's getting very close to the standard algorithm. And it also shows how she added, based on place value, ones and ones, tens and tens, and so on. And she's keeping that place value as the foundation of her reasoning. And finally, I showed Ashley's work, which was the standard algorithm, and which is what this standard calls for. And as I charted and the students explained their work, I asked other students to make connections between the different representations. And my big lesson there was that by allowing them to use the representations and strategies they were more familiar with, and by sequencing the work from more concrete to more abstract, they were able to make the connection from the most concrete to the standard algorithm. So finally, for the exit slip, I gave them a 2 multi-digit number, and I asked them to attempt solving it using Ashley's way, which is the standard algorithm, which I did not even that day name that it was called the standard algorithm until the following day. And for this lesson, it was Ashley's way, and she felt all that pride for, showing her work, and the students felt like they learned from their peer. And until the next day, we gave the official name for the algorithm that Ashley showed.
Can we just go back a slide for a second to the anchor chart? So I had the privilege of being in Muriel's classroom while she taught this lesson, and it was she did such an amazing job of that idea of like pushing kids encouragingly and supportively. Every student was affirmed in the work that they did, but when she got to the whole class discussion, she had a really clear idea of who she wanted to share. And if you look closely at the poster, you'll even see she uses color coding to help connect parts of the model. So it was just a thing of beauty. If anyone is in Orange County, California, or really Southern California, you should tweet at Muriel and see if you can go visit her classroom, because it's a joy to be in. All right, now we can go to the next slide. So just like we saw with the OA progression, we see a lot of textbooks doing the same kind of breaking the strategies or models in this case down into separate lessons. So one of the things that we first noticed looking at this, this is a second grade table of contents, is that lesson 3.1 and 3.2 are asking students to do the same thing, and they're just asking them to use different representations to do it. And this gets confusing for kids and for teachers. Is the lesson about using the hundreds chart versus the open number line, or is the lesson about adding tens? And you'll see as you continue to read down, these strategies that are named differently maybe aren't so different. And as Muriel said, it's really important to think about how the representations that we're using, oh goodness, and the strategies that we're sharing are building kids towards that place value, understanding, and development. So if you have a book that looks like this, thinking about how instead of teaching 3.1, 3.2, 3.3, how do you bring out the mathematical idea and let students use a representation that makes sense to them with where they are in the progression? One other thing that we see is when we see textbooks where they are focusing on students describing the models is a question like this. So the idea was to bring writing into math. There's a word list for kids to use, and the student described a way to find 47 plus 18. I can use an open number line to solve 47 plus 18. Unfortunately, this kind of question is a waste of time. It's not telling us anything about what the student knows about addition. It's not telling us anything about how they're reasoning about those numbers, and it's not really helping prepare for algebra. Whereas if we're asking kids to just do the math, we can learn a lot from what they're giving us in terms of how they represent problems. So we're going to end where we started with our slide that shows the progression to addition fluency. And you know, the big message here is really thinking about this as shared work across the grades. The progression is slow and it's deliberate to make sure that students really have the ability to develop the expectations of each grade so that they can build from it and get to that idea of fluency with the standard algorithm with multi-digit addition and subtraction in fourth grade. So I encourage you, as you're thinking about returning back to school, thinking about how to share this information vertically at your school and really talk to the across the K-3 teachers about how students are progressing and what the responsibilities of each grade are.
Great, thank you, Marnie and Muriel, for such a great webinar. We've gotten lots of people commenting in the question tab about the value of what they're learning and what they're hearing, so thank you. We're going to pause for a minute and see if there's any questions for our guests. We have a few minutes left to ask some of the questions. I know, Tori, some of you have been asking questions throughout, and Tori's flagged a few of those questions, but I think I will start us off with just one question, and then maybe, Tori, you can look for a second question to ask either Muriel or Marnie. So Marnie, one of the questions that has come up already is, are there resources for developing fluency, or where do you suggest people go, especially if their textbooks do what you showed in the last two sections and teach different strategies every day?
Yeah, so because we know this is such a challenge in textbooks, if you go to Achieve the Core, we actually have documents by grade level that have compiled activities to help develop fluency. We created them originally as part of a project we were doing specifically with GoMath, but we've gotten feedback from users of all different programs that they're a great resource. So I'm hoping that someone can send that out in the chat box so that we have the link for everybody.
Great.
I will do that for sure.
Perfect. Lots of folks are asking about these beautiful slides you're seeing tonight. Don't worry, you'll be getting a link to the recording of this webinar and the materials, and they'll also be posted to our website, Achieve the Core. Wanted to hop to another question now. There are lots of questions coming in about kindergarten, and I think this could apply to other grade levels as well. but some questions around what is quote unquote fluency at kindergarten and what are the best ways to know if your students are fluent and get on the same page with your colleagues about different interpretations of fluency.
That's a great question. What's kind of neat about the kindergarten expectation for fluency is if you write out the facts for what counts as addition within 5, there's a very limited number of facts, and most of them end up being +1, +2, or +0. So there's something really important about keeping that limited that connects right to the work in kindergarten that you're doing so much with counting and thinking about the meaning of addition. And so to deeply teach the counting and cardinality standards and to deeply teach the meaning of addition often means there's just a little more practice for students to be able to have that fluency, so to have a quick answer. I would say the definition of fluency definitely varies in different places, but I think one way to think about it is, are the students able to access the answer fast enough that they can do something with it? Can they apply it? Can they use it with larger numbers? And once students have that, then they have the skills that they need as they're moving forward.
Great. We had another question come in about helping pre-K. Actually, we have a pre-K teacher in attendance, and also maybe this could be helpful for parents as well, but just thinking about what types of things might help prepare kids before they get to kindergarten.
Yeah, so my favorite resource for thinking about the ramp up to kindergarten is the book by Doug Clements and Julie Sarna, I think is the last name, about early learning trajectories. It's really helpful for looking at what students start developing as early as 2 years old that then lead to this work that they're going to do with addition and subtraction. But I think, you know, the basic concepts around counting and what it means to count and what happens when I count are huge in really setting kids up for success with this in kindergarten.
Great. Lots of questions about algorithms, when to teach them. If you could speak to algorithms, that would be great.
Of course. So one of the interesting things, Muriel, did you want to jump in?
Can you hear me? Can you hear me?
Yes. Yeah.
You can hear me? Okay, because I've been losing the connection. Are we talking about addition and subtraction algorithm?
Yep.
Yeah.
Okay. I would say then the question was when you teach it in 4th grade, because the standard calls for teaching the algorithm in 4th grade. And before that, students should really focus on that conceptual understanding and with the fluency of smaller numbers. And also, if we think about 3rd grade, adding and subtracting is not even a major work of the grade. Multiplication is. So in 3rd grade, they're going to be focusing a lot on that multiplication and division. And so we leave that standard algorithm for addition to 4th grade.
Yeah, and I would just add the language of the standards could allow for the standard algorithm to be introduced earlier if it's introduced as a strategy based on place value. So you see that in both the 2nd and 3rd grade standards, that it talks about strategies based on place value. So there is a way to introduce it earlier, but I think what we see most often is that students are coming in having been taught the standard algorithm as a procedure, and they don't have the conceptual understanding or the understanding of place value that they're going to need going forward.
And Marnie, would you, conversely, a question came up about what if students come to school in, say, 1st grade or 2nd grade, and their parents have already taught them the standard algorithm? What would you do about that?
Yeah, it's a great question. I'm sure pretty much everyone has dealt with some version of this. You know, I think there's 2 parts to this. One, I think, is educating parents on why the standards are constructed the way that they are and what the progression looks like. You know, some of the things we talked about tonight might be great to share at a back to school night so parents understand why just teaching the procedure early on isn't helpful to students' future mathematical work. And I think the other way is just to push students to make sure they have the understanding and thinking about asking conceptual questions that require students to think a little bit more about the numbers than just doing computation every time. We have a great example of that in a different slideshow that maybe we can add to this before we send it out to everyone.
And Marnie, I also wanted to add that I have seen cases of that, and if you just kind of ask those conceptual understandings sometimes of students of why they're doing what they're doing with the algorithm, many of them are not able to explain why they're doing it. So then you need to go back and make sure that they do have that conceptual understanding behind that procedure.
Great. Thank you, Marnie and Muriel. We appreciate so much your time this evening and helping all of us dig into this complicated topic. I just wanted to share before we do our closing slides that, again, I know Tori already said this, but we will be sending out the PowerPoint slide deck and the handout and the recording, and all of the hyperlinks that are in the PowerPoint will be available for you to just click on, and we'll go ahead and add in some of those extra resources. And if there's questions that weren't answered on tonight's webinar, we'll go ahead and continue to type them in the question tab and we'll try to address them. So just to close us out this evening, if you found tonight's webinar helpful, we'd like to invite you to join our Core Advocate Network. We're committed to solving real problems that real teachers have, and we know the best way to do this is to know more about what folks are experiencing out in the field. So as part of our national network, you have the opportunity to connect with educators across the country, maybe even the network that's specific to your state. We have quite a lot actually, of state networks. And you can keep up to date on tools and resources that are available on Achieve the Core, as well as a variety of other virtual learning opportunities, including these webinars and mini courses, and even maybe some other ways to engage with us. We also work with educators in our network to help us build tools and resources and to give us feedback on our tools and resources. So we'd love to have you be a part of that. By taking our survey, we learn about who you are and where you work and the types of things you're interested in and the expertise you already have. This way we will be able to tailor our webinars and other opportunities to your needs and interests. And we may even tap you to be one of our next webinar guests. So we encourage you to join the network by filling out the survey at achievethecore.org/CA-signup. You can also engage with us in a variety of ways. Many of you have already joined us on Twitter and joined the conversation about the webinar tonight. So you can follow us at Achieve the Core. And we also are active in posting about our tools and resources and upcoming opportunities on Facebook and Pinterest. And finally, we would like you to invite all of you to share what you're already doing more broadly around standards-based instruction and materials and assessments, whether you're trying a strategy or a tool, or whether you're using something from the webinar tonight. Maybe you're sharing the webinar with colleagues. We'd like to know what you're doing and how it went. So you can use this form, achievethecore.org/educators taking action, to let us know about your advocacy. And again, we might hear something which would prompt us to call you up and say, we'd like to come see what you're doing. And maybe we'll invite you to be on a webinar in the future. So we're excited to finally share with you some opportunities to join us in 2018 to learn with us. We will be hosting a webinar the first Wednesday of each month at 7 o'clock p.m. Eastern Time, except for September because of Labor Day. It's the second Wednesday, but this is sort of our lineup through January. On September 8th, we're going to talk about leveraging Pear Deck to actively engage students. If you're interested in intentional use of technology, we hope you'll join us for that one. October 3rd, we're going to talk about setting and keeping professional learning goals, and we're going to ground that in our instructional practice guide tool. And so it's a good way to kick off the learning for the school year for educators. On November 7th, we're going to talk about math language routines, the what, the why, and the how, and that'll be really connected with a lot of the work we've been doing around how to meet the needs of English language learners in the classroom. We don't have a specific topic yet for December 5th, but we have some ideas, and we know it's going to be around literacy, so that is to be determined. And on January 9th, we'll be talking about foundational reading skills, instruction in action. So again, our next month's webinar is leveraging Pear Deck to actively engage students. We will have some content embedded in that webinar as well. So that's going to be Wednesday, September 12th. It's going to be a mini webinar, so it's going to be just 30 minutes long. And I know that's a super long link for registration, but when you receive the slide deck from tonight's webinar, you can go ahead and just click on that to register for next month's webinar. So again, we appreciate you joining us for this August evening. I know many of you are just going back to school or finishing out your summers, so we appreciate you being here. And we're actually even 2 minutes over, so if you're still on the line, thank you for hanging with us, and we hope to see you next month for our next Core Advocate webinar.